problems in 5 categories. So in this video, we are going to look at each of these 5 categories so that we can easily identify the mixture problem that comes in CAT exam and we can solve it by appropriate concept. We are also going to look at 10 previous year CAT questions, including the ones that have appeared in 2021 and 2020. So please watch this video till the end and don't forget to hit the like and share button. Okay, just want to tell you that if you want to master this concept of mixture, if you want to solve all the questions of mixtures, you should be very good at percentage, ratios, of course averages, and you should also be good at numbers. When I say numbers, so of course general calculation, along with that HCF LCM concept. So if you are good at these concepts, you can safely proceed with this video, and I'm sure after this video you will feel more confident about solving the mixture problems because you will be able to classify in the appropriate category. So let's look at the first category. It's the most easy category of questions that have come in the CAT exam and of course will come in future also. In this particular variety of question, or in this type of question, what you are given is, you are given say 2-3 different varieties of mixtures with the same ingredient. Say for example, we have 3 mixtures of A and B and we are mixing them in the ratio say 3:2:1, something like this, and then we'll be asked to find out fraction of A in the resultant mixture or quantity of A and B in the resultant mixture, and so on and so forth. This is very easy. The only thing that you should be good at is numbers. You should be able to quickly find out LCM of different ratios in which they are given. So we'll look at one question and you will understand that. This is the first variety. Then the second variety is simple allegation problem. The only thing that they'll do is, instead of giving directly to cost, what they'll do is they'll give you the cost price of ingredients and they'll give you the selling price with certain profit for the mixture. So you will have to calculate cost price and you will have to figure out in which ratio should be mixed. So of course they'll do a bit of twist and turn over there. The third variety is where you are given a mixture and then you are removing part of that and replacing with pure quantity of say one of the ingredient. So we are removing some mixture and we are mixing it with say pure B. Again, this variety can be solved by rule of allegation only. Here we can use concept of percentage also. So I'll show you how to use concept of percentage over there. Then the fourth variety is a compound mixture where we have 2 mixtures and we are mixing them to create another resultant mixture. We use concept of fraction over here. So I'll show you a couple of questions which are based on this method. Yes. Okay, and the fifth and the last variety is very much known to all the students, which is removal and replacement. Again, this questions will be very easy to solve. So let's take up the question and let's see how to apply this concept. So here I have mentioned the type of the question based on what I have categorized at the beginning. So T1 means it's a type 1 question. As you can see over here, so there are we have 3 mixtures, first having water and liquid A in the ratio 1:2. So let me just write down. First mixture has first mixture has water and liquid A in the ratio 1:2. This is from CAT 2017, by the way. Then the second mixture has water and liquid B in the ratio 1:3, and the third mixture has water and liquid C in the ratio 1:4. Okay, now these 3 mixtures of A, B and C respectively are further mixed in the proportion 4:3:2. So we are mixing these 3 mixtures in the ratio 4:3:2. That means if I take 40 liters of this, I'll have to take 30 liters of second mixture and 20 liters of the first mixture, something like that. But should I proceed with this 40, 30 and 20? The answer is no, because if I take 40 liters of first variety, it will be difficult for me to bifurcate in the ratio 1:2, divide in the ratio 1:2. So I need to have this number, this first number, in a multiple of 3. So I'll have to multiply all the terms of the ratio by 3. Similarly, now this will become 120, 90 and 60. So we need to divide the second quantity in the ratio 1:3. So it should be a multiple of 4, while right now 90 is just divisible by 2, not by 4. So we'll have to further multiply this one by 2. So now we are multiplying each of this by 6 actually. Okay, now let's see. So this will be taken care, this bifurcation will be taken care. We are using basically concept of LCM over here, and this 1:4, that means total is 5. So we should be able to divide this quantity in 5 parts. Yes, If I take 120 liters over here, it can be divided in 5 parts. Similarly, this will become 180 liters and this will become 240 liters. I really hope all of you have understood how have I come up with this quantities, right? So now my question is actually very simple. You know, this mixture alligation question, if you look at CAT exams mixture alligation question, most of the question, I'll say about 80-85% of the question can be solved in just 1 minute's time. For example, this question, because there are some calculation involved, it will take probably 90 or 100 seconds, but we'll look at some other questions, it can be solved in just less than 60 seconds, I believe. Okay, so now let's quickly divide this first mixture, this 240 liters in this ratio, so it will be 80 liters and 160 liters. You should be very good at calculations over here. Similarly, 180 divided by 4 is 35, so this will be 35 liters and B will be this will be 45 liters and this will be 135 liters. 180 divided by 4 is 45, right? And similarly, this will be 24 liters and this will be 96 liters. So I can say the quantity of water, right, the total quantity of water in this three mixture put together, because we are mixing all this one. So total quantity will be 80 plus 45 plus 24, that is 149 liters. Then quantity of A will be 160 liters, quantity of B will be 135 liters, and quantity of C is 96 liters. And now you can easily identify which option is true. So option C is correct. We have more water than liquid liquid B. So I really hope all of you have understood how to tackle the calculation. Let's go to another question, which is once again based on type 1, that is simply mixing the given ingredients. Okay, so again we are given we are told that an alloy is prepared by mixing three metals A, B and C in the proportion 3:4:7 by volume. So we are taking their volume as, say 3 cubic centimeter, 4 cubic centimeter and 7 cubic centimeter. Okay, now weights of the same volume of metal A, B and C are in the ratio 5:2:6. Now this is slightly a tricky part, particularly if you are a non-engineer. Engineers would understand this very easily. So guys, what they are saying is, if I take 1 cubic centimeter of material A, then it will weigh 5 kg. Instead, if I take 1 cubic centimeter volume of material B, then it will weigh 2 kg, because the density will be less. I'm sure you can understand that, and so on and so forth. So here I can write down kg per cc. That is what is the weight of this for each material per cubic centimeter. So I can take that as 5 kg, 2 kg and 6 kg per cubic centimeter. Now, if I see what is the total quantity of material A as per my calculation, because I have assumed certain values, so this will come out to be 15 kg, this will come out to be 8 kg and this is 42 kg. So the total comes out to be 65 kg. Now let's read the question. So in 130 kg of the alloy, the weight in kg of metal C is how much? Guys, according to us, we have got 65 kg. In that, material C is 42 kg. So can I say in 130 kg, which is double of 65, C will be 84 kg. As simple as that. Once again, we can solve this question in less than 60 seconds. I'm sure all of you would agree with this. Since I was explaining, so I might have taken 20-30 seconds more, but when you are actually solving it with good calculation speed and good accuracy, of course, you can easily solve it in under 60 seconds. Let's take one more question, guys, which is straight away from slot 2 of CAT 2021, the most recent exam. A person buys tea of 3 different qualities at 800 rupees, 500 rupees and 300 rupees per kg. 800 rupees, 500 rupees and 300 rupees per kg. These are the cost price per kg. Okay, and the amounts bought are in the proportion 2:3:5. Okay, now so I can take this as 2 kg, 3 kg, 5 kg and so on and so forth. Okay, so let's read further. Let's see whether we can assume the values or not. Further, it says that she mixes all the tea and sells 1/6 of the mixture at 700 rupees per kg. Now guys, if I look at this, if I take 2 kg, 3 kg and 5 kg, the total quantity would come out to be 10 kg, and finding 1/6 of that is very difficult. So I want to make it 60 kg. So for that, I'll have to take each of this 6 times. So I'll take this as 30 kg, I'll take this as 18 kg and this as 12 kg. So total quantity will become 60 kg. Now what is my total cost? My total cost over here is 9600 rupees, 9000 rupees, and again 9000 rupees. Very easy to calculate this, right? For this 60 kg, my total cost is how much? This total, if we add, it will come out to be 27,600 rupees for 60 kg. Now it says that further that she mixes all the teas and sell 1/6 of the mixture at 700 rupees per kg. So she is selling 1/6, that is 10 kg at 700 rupees per kg. So definitely she'll get revenue of 7,000 rupees over here. Okay. At which price she should sell the remaining tea? That is, now she has to sell remaining 50 kg tea so as to make an overall profit of 50%. Now what is my total cost? My total cost is 27,600. I hope all of you are able to see that, and we want to make 50% profit in that, so we'll have to add half of that. So I'll say 13,800 rupees will be added. So total will come out to be how much? Right, so total will come out to be, I can say, 41,400 rupees. This is the total revenue that I need to generate. Of course, I have already sold 10 kg and I have generated 7,000 revenue. So 41,400, 7,000 has been already generated. So how much more revenue do we need to generate? 34,400 rupees revenue we need to generate more. Isn't that? 34,400, right? By selling this 50 kg. So what will be the per kg price? 3440, 440 divided by 5 is 88. There is only one option ending with 88, so we can tick mark option B. Now this question was a little more calculation intensive, so even if you are spending say 2 minutes in such question, that's perfectly fine, but I'm sure all of you would agree that simple mixing of the given ingredients, you don't need to apply something like alligation, or you don't need to use complicated fractions over here. It's a simple calculation based question. Okay, now let's go ahead with one more question and let's see once again. Now this is based on variety 2, which is like a application of rule of alligation. So a trader sells 10 liters of a mixture of paint A and B, where the amount of B in the mixture does not exceed that of A. That amount, in the sense they are talking about quantity. Okay, the cost of paint A per liter is rupees 8 more than the cost of paint B. So paint B is our cheaper ingredient, paint A is our dearer ingredient, and we are told that the difference between the prices, difference between their cost, has to be rupees 8. Okay, if the trader sells the entire mixture at rupees 264 and makes a profit of 10%, now the moment you see these numbers 264 and 10% profit, so we should be able to make out cost price of this 10 liters of paint. Cost price of 10 liter is 240 rupees, because only on 240 rupees if I add 10% profit, it will become 264. So cost price of 10 liters is 240. So what will be the cost price of 1 liter? It has to be 24 rupees. Isn't that? So by mixing this two, we are creating a mixture which costs rupees 24. Okay, now what we are told is quantity of B should be less than or equal to quantity of A. Remember that quantity of B does not exceed A. That means it can be equal to A or it can be less than A. Our question is, what is the highest possible cost of paint B in rupees per liter? By looking at this statement, highest possible cost and the difference of 8 and the average price of 24, I should be able to get this thought that what if I take this as rupees 20 and this as rupees 28 and we are mixing them in equal proportion. Okay, so center, the average will be the center value, that is 24. Okay, now can I increase this B price from, instead of 20, can I make it 21 or 22 or something like that? The answer is no, because we need to keep this difference of 8. If I make this one 21, I'll have to increase this again if I keep the same proportion, right? So I'll have to make this as 29 to keep the difference of 8, and this will not come out to be 24. So that's how we can make out the quantity of B. When we keep quantity of B less than A, the maximum price of B can only be 20. So answer for this question is 20 rupees. So I really hope all of you have understood this question as well. Let's take one more question. But before that, guys, just want to quickly tell you, in case if you are not familiar about my sessions, what you can do is you can just be part of my Telegram channel. The QR code is displayed and the channel ID is also displayed, so that you can get update about all my daily live sessions. I'm conducting daily live on YouTube every day at 6 p.m. So do join that. And apart from that, if you want, you can also learn with me through my Plus and Iconic courses. Join Plus or Iconic using my code CHART10 to prepare under my guidance. Fine, guys. Now let's look at this question. This is straight from CAT 2021 slot 1. And this question is actually very easy question. You can solve it in 60 seconds time. And this is simple application of this rule of alligation. The only thing is, look at the first line. The strength of an indigo solution in percentage is equal to the amount of indigo in grams per 100 cc of water. This is something that you know, it's a fact. For example, when I say I have 90% acid solution, that means in the quantity that I have, 90% is pure acid and remaining 10% is water. So this is what something that they say. So this first line can actually be ignored. Don't be bothered by such lines in exam. They are just simple definition. Okay. So now the question says that two 800 cc bottles are filled with indigo solution of strength 33% and 17%. Let me just depict the solution. We have two bottles of 800 cc, or you can say 800 ml, whatever you want to understand. It's a volume. Okay, and it has the indigo solution and the concentration is given as 33% and 17%. So this is the first bottle, this is the second bottle. We are indicating indigo by blue color, so it has, yeah, this is 33% solution, first bottle, and in the second one we have this 17% solution. Okay, a part of the solution from the first bottle is thrown away. So what I'm doing is I'm just emptying this part, I'm throwing it away and replaced by an equal volume of solution from second bottle. So you are transferring this over here. Okay, so can I say what we are doing is we are mixing this 17% solution with 33% solution. Okay, and as a result we are getting a solution which has concentration of 21%. Very simple. So you can easily apply that rule of alligation and you can make out this is 4 and this is 12. So we have mixed this two in the ratio 3:1. That means if this is 1 liter, what I have added from bottle 2 has to be, if this is 1 part, then this has to be 3 parts. Okay, the total we know is 800 cc. So can I say this has to be 200 cc and this has to be 600 cc. So we transferred 600 cc to first bottle. So what is the amount or the quantity of solution 2 left in the second bottle? Okay, solution of indigo left in the second bottle, it has to be 200 cc, and that is what they are asking. Then the volume in cc of solution left in the second bottle, so you can straight away say it's 200 cc. I really hope you have understood this. So even if you are spending say 90 seconds for this question, it should not harm you. But because you have plenty of time in CAT exam, right? As you know that even if you solve say 6 to 7 questions, 7 questions correctly, you will get 90 plus percentile in CAT in quant section. So I'm sure if you go ahead with this pace, you can easily solve 12 to 13 questions, which will get you something like 99.78 percentile. Okay, so let's look at variety 3. What is the variety 3? That we have a mixture, we are removing some part of that and we are replacing with some pure solution. Okay. Right. So solution of volume of 40 liters has dye and water in the proportion 2:3. So it's very simple question. Okay, 40 liters of solution we have, and we have dye and water in the ratio 2:3. So let me just write out 40 liters, it has dye and water in the ratio 2:3. So how can you divide 40 liters in the ratio 2:3? You can say dye is 16 liters and water is 24 liters. Right. Yes, we have dye 16 liters and water 24 liters. Now what we are doing is water is added to this solution to change the proportion to 2:5. Okay. So we are adding this water and we are making it 2:5. So 2 parts are 16 liters. So 5 parts have to be 40 liters. So we have added say 16 liters of water in this. So now we have 16 liters of dye and we have 40 liters of water. Very simple question. If 1/4 of this diluted solution is taken out. Now guys, if I take out 1/4 of this, so can I say 4 liters of dye will be removed and 10 liters of water will be removed. So I'll have 12 liters of dye and 30 liters of water. How many liters of dye must be added to the remaining solution to bring the proportion back to 2:3? We want to make it to 2:3. So can we say if this is 30 liters, so this has to be 20 liters over here. So what should we add? We should add 8 liters in this. Yeah, only then it will become 20 liters. So our answer is 8 liters of dye should be added now. Have you understood this? It's a very simple question. You are removing some part of a mixture, you are adding some ingredient, you are again removing, and then you are asked one more question. But please understand, this is not the typical removal and replacement question. It's a simple calculation based question. Okay, fine. Let's look at one more question of this T3 variety. If a certain weight of an alloy of silver and copper is mixed with 3 kg of pure silver. Now this is what I mean by T3. The previous one was a simple ratio based question actually. So we have an alloy of silver and copper. Let's call this one an alloy A. Okay, we don't know what is the proportion of silver in that. So let's assume that it has X% of silver and we are mixing it with 3 kg of pure silver. Now why have I assumed the percentage of silver? Because I'm mixing it with pure silver. So pure silver has 100% silver. So we can say we are mixing X%, okay, of A, the alloy A, which has X% silver, we are mixing it with 100% silver, pure silver. I can say pure silver, okay, and the resultant alloy has 90% silver by weight. So the resultant alloy has 90% silver by weight. Now we know that we have taken 3 kg of pure silver, but we don't know how many kg of this alloy was taken. So let's put it aside and let's look at the second scenario. They must have given some additional information. Right? If the same weight of an initial alloy, that is alloy A, which has X% silver, if we mix the same weight, is mixed with 2 kg of another alloy. Let's call another alloy as alloy B. So we are mixing with this B and it has 90% silver. So yeah, alloy B has 90% silver in that. So we are mixing this 90% alloy with X% of A, X% alloy. The resulting alloy has 84% silver by weight. So this has 84% as the average weight. Okay, the resultant mixture has 84% silver. Now one thing is for sure, that we have mixed the same quantity of this alloy A and we have mixed 2 kg of this alloy B. Okay, and this X has to be definitely less than 84%. Only then we are mixing it with 90%, we are getting average as 84%. So we know this X is definitely less than 84%. Okay, if you look at the options, we have 3.5, 2.5, which are slightly complicated. If I take 3.5 over here, so this will actually make it very complicated. It will not gel with the numbers. For example, 3.5 and 3, so that means you can say this is 7:6. 7:6 ratio, I will not get it because 100 minus 90 is actually 10. It doesn't gel over here. But instead, if I take 3 kg over here, that means I am mixing them in the ratio 1:1. So 100 minus 90, if this is 100%, this you can straight away make out this has to be 80%. So only then we can say 80%, 100%, you are mixing them in the ratio 1:1, you are getting average as 90. Isn't that very simple? So let's see whether this 3 kg gels over here or not. So if I take 3 kg over here and 2 kg over here, so I am mixing them in the ratio 3:2. 90 minus 84, so of course X has to be 80 as what we have received over here. So 80, 90 minus 84, it will be 6. 84 minus 80, it will be 4. 6:4 is nothing but 3:2. Yes, you are getting that. So it has to be 3 kg of the first alloy. Now this is a different approach that I've used because the options were supporting this situation. In certain situation, you may have to do the complete calculation by making equation. It will make it slightly complicated. But if you look at most of the CAT exam, most of the CAT exam questions, they're not very complicated, barring 1 or 2 questions. Otherwise, you can solve them by this kind of trial and error method. Okay. So let's look at one more question, and this is of T4 variety. We can say T4 variety. What is the T4 variety? It's compound mixture problem. You have 2 mixtures, you are mixing them and you are creating another mixture. So that is called mixture of mixture, or you can say compound mixture. Right. So class A has boys to girls ratio 2:3. Class B has girls to boys ratio 5:3. Please understand this is girls to boys. Okay. If the number of students in class A is at least twice as many as number of students in class B, what is the minimum percentage of boys when both the class are considered together? Okay, question looks slightly difficult, but we can simplify this. Since they are asking in percentage, let's find out percentage of boys in both the class. Okay, so in class A, can I say boys to girls is 2:3, so we have 40% boys. Similarly, in class B, girls to boys 5:3, so fraction of boys is 3/8, or you can say it is 37.5%. 3/8 is 37.5%. You should be very good at that fraction and equivalent percentages. Now guys, one thing's for sure, irrespective of what is the question, can I say if I mix these two, the resultant mixture will have all the average value, or the mixture percentage will always be between 40 and 37.5? Yes or no? So this option is eliminated, this option is eliminated, this option is eliminated. We are left with only one option. So even this kind of questions have been asked in CAT exam. Please be very careful, always keep an eye on the option. Okay, this was actually a very easy question, nothing has to be done. But look at this question. Once again, it is of T4 variety. So this is a nice question, but once again I'll call it an easy question. So let's see how to solve this question. 100 kg of an alloy of tin and lead in the ratio 1:3 is mixed with X kg of an alloy of tin and lead in the ratio 3:2. If the overall alloy should contain between 40% and 50% tin, what is the range of values X can take? Once again, they are giving me data in percentage. So what I'll do is I'll assume that this first alloy, let's call it A, has 25% tin, 25% tin. X kg of second alloy, let's call it alloy B. It has a ratio of tin and lead in the in 3:2. So can I say it has 60% lead? It has 60% tin. We are doing calculation in tin because we are given final percentage between 40 and 50 for tin. Okay, right. Now let's solve this question. So we are mixing A with B. This is 25%. This is 60% tin, and we are mixing. Now they are saying we need to keep the final percentage of tin between 40 and 50. So what if I keep this as 40%? So what will be the value of X in that case? So guys, we are taking 100 kg of A. So here we are taking 100 kg. Remember that, and we need to find out what value, what weight can we take over here. So first of all, let's solve this by rule of alligation. 60 minus 40 is 20, and 40 minus 25 is 15. So instead of 20, we have 100 kg. So can I say instead of 15, we should have 75 kg over here. So the minimum weight of tin can be 75 kgs. Okay, there is only one option. Guys, this has to be less than sign over here. Right, so there is only one option. We really don't need to check for others. But in case if we check for others also, we'll get that option D as the correct answer. Let's see how. So now we know this is 100 kg. So let's keep it fixed. Now if I make 50 kg over, if I make this lead percentage in the final mixture as 50%. So 60 minus 50 will come out to be 10. 50 minus 25 will come out to be 25. So instead of 10, we have 100 kg. So now it is 10 times. So instead of 20, it has to be 250 kg. So yes, the value of lead can be anything from 75 kg. Sorry, value of the quantity of B can be anything from 75 kg to 250 kg. It has to be between that because we need to keep this percentage between 40 and 50. ऐसा mention नहीं किया है कि including 40% and 50%. So yes, we'll also keep the weights between these two, and that's why there has to be less than sign, not less than or equal to sign. So answer is option D. I really hope all of you have understood this question. Guys, we have taken 9 questions up till now. In last about 12-13 minutes, we have solved 9 questions. Okay, let's take one more question, and this is of variety T5. From a jar which is removal and replacement, very simple variety. From a jar containing X liters of milk, 4 liter, we don't know what is the quantity of milk in this jar. It has X liters pure milk. Okay, so this is pure milk. We are taking out 4 liters of milk and we are replacing it with water. This process is repeated one more time. If the percentage of water in the jar is 36%, 36% means, can I say it's 9 by 25? So 9 by 25 is water. So can I say milk has to be 16 by 25? So now we can apply that removal and replacement formula. Milk left upon initial quantity of milk, initial quantity of milk. Yeah, so that we know as 16 by 25. Fraction of milk left is milk left upon initial quantity of milk, and this is a minus b upon a whole raised to n. N will be over here 2. Okay, so if I take square root of this, what is value of a? So a is nothing but x. That is what we need to find out, initial quantity, and we are removing every time 4 liters, right? So guys, if I solve this one, I'll straight away get x as 40 liters. Very simple to make out. Yeah, I'll get x as 40 liters. So every time I'm removing 4 liters out of 40 liters. Yeah, let me just solve this, by the way. 4 by 5. So this will be slightly different, I believe. It is going to be 4x is equal to 5x minus 20, or you will get x is equal to 20 liters. Sorry, it will come out to be 20 liters, not 40 liters. There is some typo over here, so x has to be 20 liters, right? So this is how you can solve all the questions. So whenever you come across any mixture alligation question, try to think of this 5 variety. What you need to do, is it a simple addition of some different mixtures in a certain proportion? Use LCM concept, try to make the quantity such a way that numbers are very easy to bifurcate, right? Second is application of rule of alligation. Third one is, you have a mixture, you're removing some part of that, adding a pure ingredient, so that variety. The fourth one is compound mixture, so you can do calculation in percentage or in the fractions. And the fifth one is removal and replacement. If you look at any of the CAT questions, they can be mostly categorized in one of these 5 categories. So I really hope all of you would have enjoyed this video, this particular video, and you would have learned the concepts thoroughly.